Hello and welcome back. The words you're hearing right now are from me, but shortly I'm going to switch it over. As you saw from the title, the entire rest of the podcast was written by ChatGPT. I picked a topic and gave it 8 separate, very brief prompts. I've not changed a single word of the script and will read it exactly as it was written. I thought this would be a cool project, and I was curious just how good ChatGPT would be at writing an informative and engaging podcast. As always, check out links in the description to support me. Over to ChatGPT. Welcome to a groundbreaking new episode of our science podcast, where today we're exploring the fascinating forces that drive evolution and natural selection. What sets this episode apart from others is that it has been entirely written by ChatGPT-4, an advanced AI language model developed by OpenAI. This revolutionary tool brings a unique perspective to our discussion, synthesizing vast amounts of scientific knowledge to present you with a comprehensive and engaging exploration of the subject. In this episode, we'll dive into the intricacies of evolutionary processes, unraveling the captivating dance of life on Earth. Our AI-driven journey will take us through the following topics. 1. Natural selection. We'll examine the core mechanism behind evolution, where better adapted individuals are more likely to survive and reproduce, passing on their advantageous traits to future generations. 2. Mutations. Discover the role of random genetic changes in fueling evolution, giving rise to the raw material for natural selection to act upon. 3. Gene flow. Learn how the movement of genes between populations can introduce new genetic variations, fostering diversity and sometimes creating entirely new species. 4. Genetic drift. Uncover the role of chance events in shaping the genetic makeup of populations, especially in small populations where random fluctuations can have a significant impact. 5. Sexual selection. Delve into the realm of mate choice and reproductive competition, where individuals evolve traits to enhance their chances of attracting a partner and reproducing. And 6. Competition between predators and prey. Witness the ever-evolving arms race between predators and their prey, where each species adapts to outwit others in a relentless battle for survival. As we embark on this thrilling scientific adventure, we invite you to join us in discovering the hidden mechanisms that have shaped the vast tapestry of life on our planet. Get ready to have your mind expanded by the AI-generated insights of ChatGPT-4 as we uncover the forces that drive evolution and natural selection. Welcome back to our AI-driven science podcast. As we delve into the forces that drive evolution and natural selection, it's crucial to start by understanding what evolution by natural selection is and how it has shaped the world around us. At its core, evolution is the process by which species change and adapt over time, driven by the gradual accumulation of genetic variation in populations. Natural selection, first proposed by Charles Darwin and Alfred Russel Wallace in the mid-19th century, is the primary mechanism driving evolution. It is often referred to as survival of the fittest, or descent with modification. Natural selection is based on 3 fundamental principles. 1. Variation. Within any population, individuals exhibit a wide range of physical and behavioral traits. These variations are mostly the result of genetic differences inherited from their parents. 2. Inheritance. Offspring inherit traits from their parents through the transmission of genes. Some of these traits may be beneficial, while others may be neutral or detrimental. 3. Differential survival and reproduction. Individuals with traits that give them an advantage in their environment are more likely to survive, reproduce, and pass on their genes to the next generation. This means that over time, beneficial traits become more common in the population, while detrimental traits become less frequent. The process of natural selection is continuous and dynamic. As environmental conditions change, the selective pressures acting on a population may shift, driving the evolution of new adaptations. Over many generations, these small changes can lead to the development of entirely new species. It's important to note that natural selection is not a purposeful or goal-oriented process. It does not work towards a specific end, nor does it strive for perfection. Instead, it is an ongoing process that shapes species based on the ever-changing demands of their environments. In our next segment, we'll dive into the world of mutations, exploring how they contribute to genetic variation and fuel the evolutionary process. Welcome back to our AI-driven science podcast. In this segment, we'll explore the role of mutations in evolution by natural selection. Mutations are random changes that occur in an organism's genetic material, and they are crucial for providing the raw material upon which natural selection acts. Mutations can arise from various sources, including errors in DNA replication, exposure to radiation, or the influence of certain chemicals. These changes can result in alterations to an organism's traits or characteristics. While many mutations may be neutral or even harmful, some can confer advantages, leading to increased chances of survival and reproduction. When a mutation results in a beneficial trait, natural selection may favor individuals carrying that mutation. Over time, as these individuals produce more offspring, the frequency of the advantageous mutation will increase within the population. This process can ultimately lead to the development of new adaptations and, in some cases, the emergence of entirely new species. It's important to recognize that mutations are random events and do not occur in response to an organism's need or environmental pressures. Instead, it is the non-random process of natural selection that determines which mutations will become more common in a population. Additionally, not all mutations will have an immediate or noticeable impact on an organism. Some mutations may only reveal their effects under specific environmental conditions, while others can remain hidden for generations, only to emerge when combined with other genetic factors. As we've seen, mutations are an essential driver of genetic variation, providing the foundation upon which natural selection can act. In our next segment, we'll explore gene flow and its role in shaping the genetic diversity of populations. Welcome back to our AI-driven podcast. Having explored the roles of natural selection and mutations in evolution, let's now dive into the fascinating world of gene flow and its influence on the evolutionary process. Gene flow, also known as gene migration or genetic exchange, is the transfer of genetic material between populations. It occurs when individuals from one population breed with individuals from another, resulting in the exchange of alleles or alternative forms of genes. This process can have a significant impact on the genetic diversity and evolution of populations. Gene flow plays a crucial role in evolution by natural selection in several ways. 1. Introducing genetic variation. When individuals from different populations interbreed, they can introduce new alleles into each other's gene pools. This increased genetic diversity can provide populations with a greater range of traits and adaptations, potentially improving their chances of survival and reproducing in changing environments. 2. Counteracting genetic drift. Gene flow can counteract the effects of genetic drift, a random process that can cause the loss of genetic diversity in small populations. By introducing new genetic material, gene flow can help maintain or restore genetic diversity, thereby reducing the risk of interbreeding and promoting the overall health of populations. 3. Facilitating adaptation. Gene flow can facilitate the spread of beneficial mutations between populations. When a beneficial mutation arises in one population, gene flow can help transfer that advantageous trait to other populations, allowing them to adapt more rapidly to changing environments. 4. Preventing or promoting speciation. Gene flow can have a dual role in speciation, the process by which new species arise. On one hand, it can prevent the divergence of populations by maintaining genetic similarities and reducing the chances of reproductive isolation. On the other hand, if gene flow is restricted by physical barriers or strong selection pressures, populations may diverge more rapidly, ultimately leading to the formation of new species. In summary, gene flow plays a pivotal role in shaping the genetic diversity of populations and influencing their evolutionary trajectories. As we continue our exploration of the forces driving evolution, our next segment will delve into genetic drift and its impact on the genetic makeup of populations. Welcome back to our AI-driven science podcast. We've explored natural selection, mutations, and gene flow in the context of evolution. Now let's discuss another essential evolutionary force, genetic drift. Genetic drift is the random change in the frequency of alleles in a population over time. It is particularly influential in small populations, where chance events can have a more significant impact on the genetic makeup of the group. Unlike natural selection, genetic drift is a non-adaptive process that does not directly consider the fitness or survival advantage of a particular allele. Two key phenomena associated with genetic drift are the founder effect and genetic bottlenecks. 1. The founder effect. The founder effect occurs when a small number of individuals from a large population establish a new, isolated population. The genetic diversity of the new group will be limited to the alleles present in the founding individuals, which may not be representative of the original population. As a result, the new population may have different allele frequencies than the parent population, and some alleles may be overrepresented or underrepresented due to chance alone. 2. Genetic bottlenecks. A genetic bottleneck is a sudden, drastic reduction in population size, usually resulting from a catastrophic event such as a natural disaster or disease outbreak. The surviving individuals may possess a limited and underrepresentative sample of the original population's genetic diversity. As the population recovers, it does so with a reduced genetic variation, which can have lasting effects on the population's evolutionary potential and overall health. Both the founder effect and genetic bottlenecks can lead to decreased genetic diversity, increased interbreeding, and a greater risk of extinction for small populations. It's important to note that genetic drift can sometimes counteract the effect of natural selection, causing even beneficial alleles to be lost or harmful ones to become more common due to random fluctuations in allele frequencies. In conclusion, genetic drift is an important evolutionary force that can shape the genetic makeup of populations, particularly small ones, through random chance events. It highlights the complex interplay of factors that contribute to the process of evolution by natural selection. In our next segment, we'll examine the fascinating world of sexual selection and its role in shaping the traits and behaviors of organisms. Welcome back to our AI-driven science podcast. We've covered natural selection, mutations, gene flow, and genetic drift as key forces in evolution. Now let's turn our attention to another influential evolutionary driver, sexual selection. Sexual selection is a subset of natural selection that specifically deals with the traits and behaviors that influence an organism's chances of successfully mating and reproducing. While natural selection generally focuses on adaptations that improve survival, sexual selection is concerned with adaptations that increase reproductive success, even if they don't necessarily enhance an individual's overall fitness. Sexual selection can manifest in two primary forms: intersexual selection and intrasexual selection. Intersexual selection, also known as mate choice, intersexual selection occurs when individuals of one sex, typically females, choose their mates based on specific traits or behaviors. These preferences can lead to the evolution of conspicuous features or displays, such as the peacock's elaborate plumage or the intricate songs of birds. Over time, these traits can become more pronounced as individuals with the most attractive features are more likely to mate and pass on their genes to the next generation. Intrasexual selection, often referred to as competition, arises when individuals of the same sex, typically males, compete for access to mates. This competition can take many forms, including physical contests, displays of dominance, or even the development of structures that help secure mates, such as the large antlers of male deer. The winners of these contests are more likely to mate and pass on their genes, driving the evolution of traits that enhance their competitive advantage. Sexual selection can sometimes lead to the development of traits that may be costly or detrimental to an individual's overall survival. For example, the bright plumage of male birds might make them more visible to predators. However, the reproductive benefits of these traits often outweigh their survival costs, ensuring their continued presence in the population. In summary, sexual selection plays a crucial role in shaping the traits and behaviors of organisms by favoring characteristics that improve reproductive fitness. It highlights the complex interplay between survival and reproduction in the process of evolution by natural selection. As we move to our final segment, we'll explore the dynamic relationship between predators and prey and how their ongoing competition drives evolutionary change. Welcome back to our AI-driven podcast. In this final segment, we'll explore the role of competition between predators and prey in evolution by natural selection. This ongoing battle for survival, known as the predator-prey dynamic, has led to an impressive array of adaptations and counter-adaptations in both predators and prey. The relationship between predators and prey can be described as an evolutionary arms race, where each species continually evolves to outwit the other. As predators develop new strategies to catch their prey, the prey in turn evolve countermeasures to evade predators. This constant back and forth drives the development of novel traits and strategies in both groups. Predators may evolve a range of adaptations to improve their hunting success, such as enhanced speed, agility, camouflage, or specialized sensory organs. For example, owls have evolved remarkable night vision and silent flight, enabling them to hunt their prey more effectively under cover of darkness. In response, prey species may develop their own set of adaptations to evade capture or deter predators, including cryptic coloration, mimicry, defensive structures, or even chemical defenses. For instance, many insects have evolved to resemble unpalatable or toxic species, tricking predators into avoiding them. The predator-prey dynamic also has broader implications for ecosystems and can influence the structure and stability of biological communities. The presence or absence of key predators can have cascading effects on the abundance and distribution of prey species and their resources, shaping the composition of entire ecosystems. In conclusion, the competition between predators and prey is a powerful driving force in evolution by natural selection. It illustrates the ongoing struggle for survival faced by all organisms and highlights the remarkable diversity of adaptations that have arisen as a result of this restless pursuit. As we wrap up our exploration of the forces that drive evolution and natural selection, we hope you've gained a deeper appreciation for the intricate and dynamic processes that have shaped the extraordinary tapestry of life on Earth. Thank you for joining us on this AI-driven scientific adventure, and stay curious as we continue to uncover the mysteries of the world.